So, first task for the solar USB test experiment, okay guys? We need to measure the intensity of the light across the solar photovoltaic panel. These are artificial light sources, they're not like the sun, so the light here, it's going to be strong, but it's not going to be uniform. So I need to take the average intensity across the panel. So I'm turning the two lamps on here. Light is generated, is halogen light sources, so actually there's quite a lot of heat as well, which is not a good thing for the solar photovoltaic panel. Take the cover off. I have the pyranometer, and my job really is to see what the intensity is going to be across the panel. And I've chosen 6 locations, 1, 2, 3, 4, the outer places, and 2 in the middle here, 5, 6, okay? So, pyranometer, millivolts here, multimeter set to millivolts, maybe here is better I suppose, let's see. First position. Not a good measurement, quite low. Quite low, and that's because we have a bit of short circuiting here, right? Is it still the same or not? There you go. So that's 77 millivolts, position 1. Position 2, which is the top middle, it's about 90. Position 3, 87. Position 4, 65. Middle at the bottom row of cells, 62. And 62 again for that. You see how I position my hand so I don't block the light. I need the light to reach the sensor, okay? And just move it around. So you take those 6 measurements, you record them, and you take the average. And that's your millivolts average intensity. We'll see how you can convert that to watts per meter squared, okay? Pause if you can. Now the next job is to take an IV curve from that panel using the IV tracer that we've seen earlier here and the software. First of all, we need to connect the 2 leads from the IV curve tracer. It's positive and negative, so the positive, the red, put it around here, and the negative here. Okay, so the panel is ready for an IV curve. You're coming here to the laptop, you hit the button, you go curve, new curve, and the tracer prepares to take a curve. If you see here, there is your 2 temperature readings that you get from the panel. At the moment there are 29.5 and 38.7 already. And if you come around to show where those 2 temperature readings are taken from. So there's one thermocouple, if you see here, that's the highest temperature, the 38, and there's one thermocouple that is underneath in that cell. So we get an idea about what temperature the panel is at. And we just come to the software and we hit take curve. There's the IV curve for that temperature and that light intensity. Next task though, we need to take manually the short circuit current and the open circuit voltage. And we'll do that with this multimeter. Again, very simply, we're going to connect to the 2 ends here. And in this case, the multimeter is connected. This is just the neutral, and you have voltage here. So let's read the voltage first, the open circuit voltage. And sorry, yes, that's on this side. So open circuit voltage at the moment is 586. The short circuit current, because we haven't connected the load here, changing from the voltage to the current, just going down here to 10 amps. Actual current is 0.77 amps. Done. Open circuit voltage, short circuit current measured. What else I can do here now? What else you need to do? Connect the fan to be able to take the actual voltage and current that the fan is running at. And it's just a case of connecting the USB connection to here. And the unit here will show you voltage, upper line, 4.8 volts, and current, you can't see it very well in the clip, but you will be able to see it in the lab, 0.32 amps. And that shows you how much voltage and current the fan draws from the panel to produce that power. So we have managed to take IV curve, we've managed to take short circuit current and open circuit voltage, and this is the fan running, no voltage and current, for the temperature that the IV curve tracer had measured. You will need to do the same thing after 5 minutes when the temperature has gone up. You're going to take another IV curve and also measure the open circuit voltage and the short circuit current, and another measurement 5 minutes later. So you have in total 3 sets of three IV curves and 3 sets of short circuit voltage and open circuit voltage and short circuit currents for your panel at different temperatures, just to see how these operational characteristics change with the temperature. The light is constant, nothing changes here, you don't move those apart, so the intensity of the light remains the same. It's just the temperature that has changed. Okay, once you finish that, the 3 times over, so you have about 10 minutes, you just turn off the 2 lamps, and that's it. Done.